Now we're going to take a look at an application question that will allow us to come up with a 3 by 3 linear system, which we're going to solve using Gauss-Jordan elimination. I'll let you read that while I clear out some background noise here. So we have information about 3 different types of food and also information about the percentage of proteins, carbohydrates, and iron in each of those foods. We're looking for how many ounces of each food should be included in the meal so that they get 100% of the daily requirements for proteins, carbohydrates, and iron. So number one, notice that all of these entries here are already written as percents. Keep that. All right, so if we let X be the ounces of food 1, Y be the ounces of food 2, and Z be the ounces of food 3, then our columns in the table correspond to the variables, and the rows correspond to a portion of the equations. Now, sometimes that will be transposed, meaning that sometimes you would want to read down to come up with your equation instead of across rows. All right. So since we have those equations, here's our initial augmented matrix. Notice that unlike what I showed in the last video where we see square brackets, here you've got a big parenthesis. It wasn't as easy with this newer version of Microsoft Word to come up with the square brackets around the whole thing. I've seen matrices written that way with the square brackets. That's what I'm most used to. I've also seen this, and I've also seen angular brackets. Nonetheless, so remember that you want to get a 1 along the diagonal and zeros elsewhere within the column, working left to right down the diagonal, using multiplication to get 1s along the diagonal. So what I do is take 1/5 of row 1 to get a new row 1. And since dividing by 5 results in terminating decimals, I left those as decimals instead of converting them to fractions. Now, dividing 3 by 5, 4 by 5, and 100 by 5, not a big deal. However, now that we have that row 1 right here, I can't select just row 1, but looking across row 1, I'm using that to change row 2 and row 3 so that I have zeros in the rest of the first column. To turn that 5 into a 0 using the 1, what I've done is I take that new row 1 and multiply by -5. I do that to the whole row and add it to row 2. Similarly speaking, we've got a positive 2.5 in row 3. So I multiply the 1 by -2.5. I do that to the entire row. And I also add that to row 3. However, I have not changed what I've written for row 1. I want to show you what it would look like if I was trying to figure out both row 2 and row 3 by hand. I'll just show it for row 2. And then I'm going to show the calculator shortcut that I showed in the previous video. All right, here we go. So here, I'm focusing on using my pivot or focus row 1, to change row 2. I'm just writing the row operations for changing row 2. So I have to multiply everything in row 1 by -5. And add it to row 2. And that's going to give me the new row 2, 0, 3, -1, and 0. Let's see if that's what I had typed up previously. 0, 3, -1, and 0. And indeed it is. Okay, but how would that get entered on the calculator? Let's see here. All right. So we were supposed to take -5 times the new row 1 plus our old row 2. -5, use the negative key, times. Remember to get 2 square brackets by pressing second, and it's above the times sign. So 1, 0.6, 0.8, and 20 for what was on the right hand side of the augmentation bar. Then square bracket closing, so that was second, and above the minus key. Apparently we have to press second both times. We're adding that to the old row 2, which was, let's see here. That was 5, 6, 3, and 100. Okay, so 5, 5, 6, 3, commas in between each of them, and 100, and then close the double square brackets. Let's see what I messed up. Comma sign. That's weird. Give me a moment here. See if I can figure out what happened. Looks like I have a decimal point between the 1 and the 0.6. See if I can fix that. So the comma. Oh, second. Nope. Give me a moment again. May have found it. Is that a comma between the 0 and the 6 in the 0.6? Let's find out if that's where my mistake was. There we go. Our 0, 3, -1, and 0. So then we were also supposed to take that latest row 1 and multiply it by -2.5, add it to our row 3. Let's see here. So I'm copying my previous work, and I'm going to change what I'm multiplying row 1 by. -2.5, and change what I'm adding it to, because what I've got there is row 2. I want to add it to row 3. All right, so 2.5, comma 2, comma 6, comma 100. Let's see if I can do that. Yes. All right, so here's what I'm coming up with. Let's see if that's what I have typed. For my new row 3, 0, 0.5, 4, and 50. That's indeed what I had come up with when I worked this out previously. All right. Now, I want to then, now that I've got a 1 on the diagonal and zeros everywhere else in column 1, moving along to column 2, I want to get a 1 here along the diagonal. I could divide everything in row 2 by 3. That would be fine, but I would not want to do any rounding. So instead, what I'm going to do is do a row interchange of row 2 and row 3, because all I have to do then is multiply everything in the new row 2 by 2. So I'm going to take that answer and multiply it by 2. That's going to give me my new row 2. And I don't want to mess up what I've got in column 1. So I had a 0.6, positive 0.6 in column 2, row 1, and a 3, a positive 3 in row 3, column 2. So I'm going to take that result for my new row 2. I'm going to multiply it by negative 0.6. Use the negative key. (0.6). And that is getting added to the old row 1. See if I can do a little bit of copying and pasting to grab that. I'm going to have to do some deleting. Delete, and delete that stuff that was following as well. All right, so I should be getting 1, 0, -4, and -40. Let's see if that's what I got for a new row 1. Yep. Okay. And our other thing was to take our answer for row 2 here. Once we've got that one on the diagonal, multiply row 2 by -3 and add it to this row 2. See if we get this new row 2 here. All right, so let's scroll up here so we can see the old row 3. -3 times what we currently have for row 2. Copy that. Why did it copy? Why did it copy? Interesting. Darn it. Okay, so that was our current row 2. And we want to multiply that by -3. And add it to the following for old row 3 to get a new row 3. Double plus sign, I'll have to get rid of that. Okay, so 0. Gotta make it where you can see both, but it's not working all that well for me. So double square bracket. All right, now I can move it for a little bit. 0, 3, 0, 3, and a -1, comma 0. Close the square brackets. Let's see if that's what I had. 0, 0, -25, and -300. It is. So I'm going to multiply all of that by -125th to get a 1 on the diagonal in column 3. And you can see the tail end of it right there. Once I have that, if I write 0, 0, 1, 12 up here, then I would have just done Gaussian elimination, and you'd have a little bit more arithmetic and a little bit more algebra to do to find out the values of the variable. But with Gauss-Jordan, I'm just going to concentrate on doing arithmetic. So now that I've got a 1 there, I want to get rid of that -4. I want to make that a 0. I'm going to multiply all of row 3 by +4, this row 3, and add it to this row 1. To get rid of the +8, I'm going to multiply this row 3 by -8 and add it to this row 2. All right, so 4 times our new row 3 and add it to, see if I can get it where you can see both. Well, let me get my square brackets first of all. Okay, so we've got 1, 0, -4 and -40. 4, -40. Come on, negative sign. And close the square brackets. So much easier to type it on an actual calculator instead of a virtual one. Okay, so 1008 in the new row 1, just as I came up with in my previous work. And when we multiply by 8, -8 actually, -8 times 0 added to 0 is still going to be 0. -8 times 0 plus 1 is still going to be 1. -8 times 1 plus 8 is going to be 0. And -8 times 12 is -96. Added to the 100, that gives us a 4. Remember that first row would be 1x plus 0y plus 0z equals 8. And that would just boil down to x equals 8. That was how many ounces of food 1, according to our definition of what the variable stood for up here. And then without actually having to write out those equations, we can just read x equals 8, y equals 4, and z equals 12 ounces of food 1, food 2, and food 3, respectively. That's all for now. Hope this helps.